So next presentation, Andrey Fefelov will represent his presentation, which will last 45 minutes. So all the questions, please raise your hands. We will bring you the mic since we have a video. And so if will not be possible to type the questions, so we want other people who will listen to this presentation, they would like to hear both question and the answer. Hello friends, my name is Andrey Fefelov. I'm working for the patroni, and I want to talk about how we choose the solutions for the fault tolerance and what is high accessibility in Postgres and how it can be realized. That's what we're going to look for, and then how we can set up the tasks. And then we'll look at the reviews and at the solutions that have been given and the task that we have solved. We'll have 20 slides in this presentation. I want you to know so that you quite aware when it will be finished. So let's start. About the applications for the high availability in Postgres, there are few approaches, and these are the names. First one is the usage of the apparent complex, which provides the fail-tolerant storage, and the second one is the usage of program complex that will help to use the replica of the block systems, and then the Postgres for the logical replica with the help of triggers or pay logic, logical and other transactions. And all these solutions have these advantages and disadvantages, and we will speak about what can be can be used by shipping. All this presentation is based on our experience. This is not the only way how it can be done, but still that's what we have experienced. In July last year, in 2018, our client, the big distributor, pharmacy distributor in Ireland, wanted to have a fail-tolerant system without Hassner failures. You make smile, but yes, we host in Hassler, and this is historically done, and Hassner is a good platform for the fail-tolerant solutions because it provides the testing on a regular basis. We decided to locate the node in Frankenstein in Nuremberg and in Helsinki, Finland. In Helsinki, it provides us VLAN, and all your servers are in one or two domains and on a switch, and they're located in one room, but with some delay in network and recovery time objective. In business requirements was 10 minutes for the switch, and without losing anything during the switching from one server to another. And this database had to do the automatic failover, both the application, if we lose some access to the internet. And the last thing was fencing. So in case of old server is out of the cluster, when it comes back, it should not become the master again in this cluster. This is what it's called fencing. This is the task that we set up before ourselves. So the first one, the 0 point, let's say this is the solution in Amazon. We wanted to be part of the Amazon, not to use Postgres at all. And so it's been actively Aurora has been used, or RDS, and we did some few tests, and they were not quite reassuring, because in case of Aurora it was very expensive, and in case of RDS maybe I haven't prepared it in the correct way, but when we ordered some good equipment and trying to deploy 70 gigabytes text done. After a couple of hours, I saw that the server is all of a sudden in recovery. I tried to reload it. Maybe it was 8th core. And I had like 16 paths, but it should not have failed, but it did. So, so it was a warning for me. I thought, okay, this is not our path. This is not the way we should do it. We also used the Parma solutions that we had in Hassler as well, and to back up externally, it was difficult. It would be difficult to do because some of the channels has their own stories, so we can take it into Amazon. So a list of difficulties that we had. We also had some big database, 1 terabyte of data. With 1 terabyte of data, so thinking about how much it will cost in Aurora, it was about 12,000 per month. So we thought that we probably could rent half of the Kastner for that amount of money. So we decided not to use the cloud solutions. We have some other solutions were also we reviewed, but they were also expensive. The first product that I wanted to review was Utility Rep Manager from second quadrant. It's written, in my opinion, in a good way. It's old, but in a good way, like old school through Postgres. It's been living through Postgres for many years, and I think it's still in development. For the high fail-tolerant systems, this is the manager for replication. When the authors try to follow with a modern trends, it's like quasi-HA. The biggest disadvantage, in my opinion, that this solution doesn't have some sort of fencing. There's workaround with external balancer, but in my opinion, this is just half of the solution. But you don't need to. You need to study the Rep Manager itself, its configuration, and daemon of RD. Rep Manager uses a very interesting idea, a witness server concept it is called. Many use this utility. Rep Manager, the server is used for the major voting. If you have the spring break, with the red line, I tried to show you the way the cluster is broken and which of servers will be the master if you have such situation. This slave on the right corner, in the low corner, because it is located together witness server. This is Postgres server, which is not included in the replica, but is included in voting. So these are the restrictions that have to do with fencing, and all of the data from the cluster are kept in Postgres. That's why I needed to look at the review other solutions. Another solution is Stolon, the product of Tolerant lab. It's very modern and quick, and it represents the product with a different concept. It uses the external distribution storage, some sort of like a proof of point of truth. The point of truth, which is relied on the distribution storage when keeping the configurations and check up the readiness of the clusters. It's operability. It's advantage of with sync and async replication, key 8S readiness. So you do not need to initiate the cluster with DB program. You need to take the cluster and bring it from the backup sometimes and deploy it, and with that initiate it. Also, Stolon supports a standby cluster, which is the correct way to use the HR solution. This is the master. You deploy the cluster with the help of Stolon. It brings in it becomes the replica for your current and the only one server. And when you make sure that your cluster is full and you've played with it, so you switch off to and from standby cluster it becomes a normal one. The restrictions for stolon, in my opinion, are the following. Since its architecture is quite unusual, it proxies all the queries only to the master node. You cannot build up or give the loading to the replica in standby cluster. And it's also very specific with switchover mode. I want to remind you that this is a planned switch over from the master to from the cluster, taking the master from the cluster. In stolon, you can take the master from the cluster, but the new master will be chosen by the cluster itself. I think this is not the right thing to do. It uses PG rewind, which can help you to bring the nodes which were lost to the cluster. But the things that need to be studied are the following. There are 4 of them. This is the architecture of stolon. This is the picture from the official documentation. The key components are the following. Proxy, Kippa, Sentinel, and the 4th one is utility, console utility that you need to study. Stolon is the only solution as the market which provides you the proxy as a part of the cluster. And the developers say that this will help you to correctly cut off transactions when the master is going from one cluster to another. Keeper is the daemon which is monitoring the Postgres status and promotes it or demotes it, and Sentinel is the daemon which follows and makes a general idea of the cluster and the distributed external storage, and so forth. These are the restrictions that the queries go only to the master, and it has a specific switch over, and many things that need to be studied brought us to the fact that we started to review patroni as well. Patroni is a product, is a framework, in my opinion, to build up fail-tolerant systems. It's been used in some of the conferences. It's also uses external distributed storage and uses async and sync. And it's similar with the functionality. It's customers and PG rewind and the client. They also uses hooks. The hooks help you to bring up the file at the node when the cluster is changing. When the cluster has a new node, or when it comes from master to slave. When something's changing in the cluster, you can do something externally. For instance, we use these hooks in order, when the master is moving to Helsinki, the external traffic should also go together to Helsinki, but not to Nuremberg, as it's been done before. So you need to study 2 things: the daemon patroni and console utility of PCL. You need to look at stolon, the documentation, and patron documentation is, you can get a full documentation of these 2, but it's better to use the initial code, initial source of the code, console. Now we move to discussion of our own setup. This is our main theme of the presentation. Why console? Patroni supports ACDC, EasyKeeper, and some other distributed storages. But console, why console? Because we've been using it for quite some time for the service discovery, for the Docker, and it has a very good user interface from the box, CDC. And the console can be operated at a DNS resolver, not like any other solutions that we have at the market. With some of the, in some of the cases, you can ask the console to bring some information for the IP address, and patroni, starting from September, it can announce nodes from master and replica inside the node cluster, and the node allows this to, through DNS requirements, master.patroni cluster service console, and through during the switching, it updates the services in the console, and you can use a very simple setup when your application uses only DNS messages. It doesn't use any other IP addresses of the cluster, and this was very helpful, and this is why we decided to use this solution. The next thing that we use in our setup is WellG, this utility which was inspired by the developers that were inspired by the previous project for the redundant storage. Why did we choose WellG? At that time we used Barman, which was a good solution for redundant copy. But when small bases were deployed for 10 minutes and the big ones for tens of hours, up to 700 gigabytes, and then it has to be copied through the network, and at some point it became the reason why we had to look up for other solutions that would support WellG is the solution which is much faster, and S3, it uses S3 as the storage and helps us in our setup to have very fast operation running. 4 gigabit or 8 gigabit channel could be used during the restore, and it helps us to shrink the data. So you have to pay for CQ, and this is not very expensive. This is production ready solution. Sometimes you can find the bugs there though, so you need to have a solution which will help you to test the backups on a regular basis, so they are deployed without any errors. And this is a solution that we have. It didn't show us LG problems, but you just need to make sure that your backups are deployed in a good way and that there are no errors. This is the setup that we have. We have 3 hosts, as I've said, and they are in different locations: Nuremberg, Frankenstein, and Helsinki. And each of the hosts, we have the console of the service of the first level, so it's not utilized, and we have containers with Postgres, and we have patroni, and patroni manages this Postgres. And if we need to initiate the cluster from SS3 and all the backups and stream WellG, and we have this solution for the last half a year, and we are quite happy with it. What are the advantages of our solution? In my opinion, this is the simplified setup compared to the setups that's like stolon, when you need to have few components and follow and monitor these components, keeper, sentinel, proxy, or other solutions, the alternative ones without DNS resolver as the usage of managing the traffic, utility hack proxy. We have fast initialization of the master of the base is empty megabytes, which takes about 2 minutes, and in Hasner network we could not get that, so thanks to WellG we can upload it very fast. And one of the important moments that I forgot to tell you about, Patroni provides REST API. Using the REST API you can get some information about the cluster in the current node. This is accessible. You can protect it with a log or the SSL key, and at any time you can ask the node what is your master or what is your slave. If it is a master, we do the backup from master and we stream the value from the archive as a master. And after the switch, you do not need to do anything manually. It's periodically, these processes are being done and we do the full backup in 24 hours.
Even if master is gone, you can ask patroni to make the backup from the different server. Nothing would happen. Failover, it really works. For the whole time of operation of a system, we get from 10 to 12. I don't remember the exact figure because there were different projects from 10 to 12 situations when failover worked correctly, and the working time, the operation time from the point the old master was lost to the time the new master was up was not more than 2 to 3 minutes, and that's great. And of course, hooks, it's just a great thing. Using hooks, we can manage external traffic, and it is called floating IP sometimes, and we can consider it as an external panel. So, well, we have an external IP address, which can then be split into IP addresses of other servers. For the whole time, HESAR had power losses or other problems. The whole system worked perfectly. The most problem was to provide correct switchover. Our system works on one host system with the base, or at least in the same data center. And if the application stays in the old data center where is no connection, it's bad, of course. But if in the old data center there is connection, but master for some reason went to Helsinki, we use RM very widely, and given the round trip time around 15 milliseconds between Nuremberg and Helsinki, we still have a big loss on production. We need to bring the application to Helsinki. Patroni allows to do it thanks to hooks. Of course, apart obvious pluses, we have also minuses in our solution. And generally speaking, solutions built based on DNS resolution could provide problems if you have DNS caching in your net, or you reached such a high load and enlightenment that you do not use DNS and go directly along IP addresses to save time on DNS resolutions. So it won't match. We initialize slave quite long. It's a shortcoming, but it's not a problem of Patroni, because in general Patroni allows to initiate replicas from external sources. But we are too lazy. We use base backup, and our master is populated in 4 minutes, and first slave needs 40 minutes to do it, because we use only one stream, and it doesn't go very fast. Also, another key feature of any fail-safe setup should be the availability and the readiness of applications to lose the database. The previous speaker told us about error handling and lack of distributed transactions. So your application should handle the loss of database in order not to create any inconsistent stories inside your infrastructure. Our applications were not ready from the beginning. We had to fine-tune them and refine them, but as a result, we improved our architecture. And unfortunately, due to the fact that Patroni uses the model of a bot pattern, as called by authors, when Patroni is the initiator system for your Postgres, which updates and starts configuration in Postgres on the nodes, it would require revisioning the orchestration system of your environment. We had to replace many things because preliminarily we made orchestration in a different way, and it's inevitably you will face it. I would like to leave more time for questions. I plan to wrap up my presentation and like to draw your attention that authors of all utilities, of the majority of utilities, and Patroni, Volg, will have their presentations today and tomorrow. Alexander Kukushkin will tell you what you should think about before building a high available cluster. Andrey Borodin will tell you about the novelties in WorldG in 2019. The links you can Google them easily to Patroni and WorldG. In the bottom we have a link to the masterclass which we had yesterday. You can open materials, you can play all the necessary things. You have a link to the Telegram channel, and in the test environments you can play today and tomorrow. It will all be available today and tomorrow for you. We have approximately 14 minutes to handle your questions. I will do it with pleasure. Please, your questions now. Good morning. Thank you very much for your presentation. You mentioned that stolon has problems with switchover. It does on its own somehow. But what about patroni? If you need some maintenance of a node, patroni has everything fine with this. He offers a master for you, the only one in your cluster, and then proposes to open a candidate for a switchover. You make it manually. In stolon, you can just pull out the master, and then if you're lucky, you get what you want. More questions? Please. Thank you very much for your presentation. What if some data gets in the old master and not in the new one? How can you transmit it by scripts or manually? It's a good question. It's a fundamental problem which everyone tries to solve depending on your conditions. I already mentioned that all solutions support synchronous asynchronous replication. You can use synchronous replication in principle to make sure that all your updates are scattered across the whole cluster. In this way, you can make sure and you can guarantee for yourself that you do not lose anything. But there are a few problems. First one, if all of a sudden your cluster, you have a completely synchronous cluster and one of the nodes is failing, the slave is failing, your transaction will not be committed until your slave is up and running. The whole cluster can be stopped in this situation. It's bad. Plus latency is bad. So there are alternative ways which we didn't use in our setup. You can make part of your nodes synchronous, other part asynchronous. Moreover, in patroni, and by the way in stolon also, a lot of time is spent for that to provide this quasi-reliability. Initially, you can't provide all three conditions, and both patroni and stolon tell you that we select partition tolerance versus consistency. It's possible to lose data. It's a real story. We found such data, but look, it can happen that master could be uncommitted in some transactions. If you use PG rewind out of the box, when you input master in your cluster, will just override these transactions. You can lose them. If you do not use PG rewind, after you detect that timelines on the slave and masters are different, old master and new master are different, you won't be able to input the slave into the cluster. You should do it manually. You should find out mismatches and transmit it manually. One more question. You showed a chart on the last slide, how you split it by nodes. Are you using a Docker or Kubernetes? We do not use Kubernetes because we're not so great to use Kubernetes, and our clients also. We use just Docker. Are there any peculiarities related Postgres in Docker? We use Postgres in Docker quite a long time, for 5 years already. Other than questions with rights, because there are roots and UIDs, we didn't see any significant problems. No drop in performance. of course, we should mount it from the outside and then get it into the Docker inside. I even like this approach. I even like it more versus the traditional Postgres. Yesterday we had a section about updates, by the way. And if you understand very well your update process, you do it manually, and in the community, for an instance, they have ready-made and proven containers which do it very fast and which is very convenient. Besides, you have images, especially customized for you. We use such images specially prepared, which fit very well in our infrastructure, and we really like it. And the last question, you speak about a production system. Do you have some system for staging, for testing? Well, and I'm experimenting now with a database of Postgres in an image, which is rolled out for tests, and then containers are killed and everything's clean. Didn't you try such a thing? Are you too big? No, not too big. Well, we do not delete it after tests. We have an environment, we have all necessary fixtures there, then we drop them, and we do not recreate the whole environment in this way. We tried to do it in the previous workplace. There were significant limitations in order to do it really fast, but it's possible to do it really fast using template. You should have a database, you can save on DDL operations, you have a template in the image, and you can make a test base out of it. It will allow you to be faster, because what you mentioned is not very fast. Thank you for your presentation. You said that patroni versus repmgr has fencing. Can you tell more about fencing, how it is implemented and how it is organized, to avoid the old master to come back, to avoid a split brain? Okay, look, patroni as stolon relies on some external source of knowledge about the cluster state. In this case, as console, someone could have DCD. The cluster of console, you do not confuse it with the patroni DCS system. So if especially the cluster and the distribution configuration management can provide the knowledge about the network infrastructure state owing raft and paxos protocols, it can detect and reselect everything. Patroni, being together with the console version, can see the cluster state. It works in a cyclical way. In another cycle, by asking this state, we see that console lost connection, and Postgres can then be moved to read-only. And when, at the moment, it won't be able to write in there. And when the connection is back, patroni will check who is the leader. By that time, there will be a new leader. The information will appear in construct cluster, and it won't bring up Postgres as a master. It's a quasi-fencing. It's quite workable and operational. Microphone, please. Microphone. How you update the application cluster? Just in a few words. We need to update the database version, the applicable application of the database. The application is deployed separately. It has nothing to do with the cluster. But in Postgres, there are objects, tables, procedures, and developers issued a new version. How to implement it in the cluster? Look, we have applications which use intensively stored procedures, and this is the case when they are part of the application. There is no problem to roll it out for cluster. And well, if you speak about Postgres update, so the stream replication excludes the work an operation of different major versions of the cluster, and we can't do anything with this. Minor versions can be updated by bringing out the node and then bringing it back. The same way you want to fine-tune some parameters of WolG or add some monitoring utility, the node is bringing out, then updated, and then brought back. If you want to update the major version, there are a lot of ways, both scheduled downtime and using logical replications. So many things which do not depend from major things. We have still time for 2 questions, please. Good morning. Who decides which requests are going for read? It's up to the application. Replicas are open for read. They are available in connection with console on all these paths, .server, .console, and the console allows also round robin. And it's the responsibility of the application not to send writes to replicas. You can use replicas otherwise, no problem. Are they available on a general address, on GNL address, DNS name, replica, timescope? Every time console allows this address, if you have 2 replicas in your cluster, just in a round-robin fashion. So the application should know all replicas. Application knows only DNS address. If we go along DNS replica, how application can know DNS? Okay, in the Docker container where you have application started or so, there is a local console node is indicated, and the console knows all the time who's the master, who is the slave. And DNS responder responses who is the master, who is slave. If we have several slaves and they are read available, they can realize the round-robin fashion and can get answers round-robin. Thank you very much. I have a question on page 18. You mentioned that during implementation you had to make changes in your orchestration. What you did with Ansibles, have you managed to integrate it, or it was replaced within the databases? Yes, we had to revisit orchestration. We didn't make any drastic changes. What we did, we had containers, vanilla containers with Postgres prepared and customized for our requirements. We used PGQ to replicate a part of tables to the analytical storage. It's one of the reasons we refused from cloud-based solutions, because it's an old story. We had some internal reasons for that. We had a vanilla Postgres, and basically it started by Ansible and deployed these containers deployed to target machines in initial orchestration. Here, generally speaking, we just had to customize and to finalize this container in order to make inside our vanilla image another utilization system. The entry point should become not Postgres data something, but patroni minus setconfig and so on. This is a minimum work, minimum debugging. Someone deploys Postgres directly to the host system, then you will need much more work. And the final question in this room, please. Thank you very much. Very interesting. In the beginning, maybe you mentioned it, but once again, please tell us. Your whole infrastructure, do you use it all for a set of systems which is existent in your case, or only for one system? You need the project. Yes, all these 3 nodes, database. As far as I understand, it's about clusters of Postgres for every node. Is it on the one system, or is it just a general infrastructure which you use? It's created for one system, it's only one project which is deployed in this way. It's not just a cloud or something. No. And what about the application? Where does the application sit? Where does it live? It lives on same hosts, and well, it's open for queries anytime according to the general configuration of the cluster. Thank you very much. Let's thank Andrey for the wonderful speech. Just 1 second. Take a look. Millions of lemmings couldn't make a mistake, but if you look at GitHub, first figure is patroni, second stolon, third is repmgr. Just take a look how these products differ, and you can make your conclusions out of this. Thank you.